This is Fall Homework 01 Debriefing. There were a few problems assigned. This begins on page 59, problem 2. Consider the two functions shown. Question 1 shown again below. Identify the form given. Write it in the other two forms if possible. If not possible, explain why. First of all, I would recognize that in A, it is written in factored form. That I can convert it to standard form by distributing through multiplying everything. So I'm going to do FOIL, first two, outer two, inner two, last two, and then multiply all of that by -2 afterwards. So doing the first two, I get x squared. For the outer two, I get 4x. From the inner one, I get 1x. 4x plus 1x is 5x. And then for the last two, 1 times 4 is 4. Next step is I multiply through by -2. So I have -2x squared minus 10x minus 2. And now I've put it into standard form. To put it into vertex form, I first find the value of the vertex, and that would be -b over 2a is the formula. B in this situation, and by the way, I'm not crazy about that minus sign in front of everything. If I were to multiply this equation by -1, I don't think it would make a difference, but we'll just leave it the way it is. So -b over 2a makes it 10 divided by -4 for the x value. -b would be +10. 2 times a would be -4. 10 divided by -4 is -5/2, or 2.5, whichever way you want to write it. Then, to establish the y value, I plug that in as the value of x for which the vertex is located. So this is the axis of symmetry, -b over 2a. And now to get the value of y, I plug that in. And I can actually plug it into any form of this equation. I can put it in the top one. What is -5/2 plus 2/2? Well, let's see, -5/2 plus 2/2 is -3/2 minus 3/2. What is -5/2 plus 4? So what is -2.5 plus 4? That would be 1.5. That would be 3/2. So what is -3/2 times 3/2? Why, that's -9/4. What is -9/4 times -2? That would be +9/2. So I'm getting 9/2 as the value of k, the coordinates of the vertex. And I see it looks like I wrote a 12, but that shouldn't be there. 9/2 is the value of k. So given that a is -2, in factored form, I have -2, open parentheses, x minus the value of h. So that's going to be +5/2, close parentheses, quantity squared, plus k. So I'm adding 9 divided by 2 as the finishing off writing 2a in factored form. In 2b, it says f sub 5 of x, that's interesting, is equal to 2 times the expression x minus 6, that quantity squared, plus 5. And I recognize that this is an upward opening parabola. Its y-intercept is at 0, 5. It's shifted to the right by 6 units, stretched vertically by 2 units, and it's currently written in vertex form. Remember, that's what we're supposed to be telling them. Now, if I wanted to convert this from vertex form into standard form, I would just get rid of the parentheses by multiplying everything out. Again, good old FOIL. Multiply the first two terms, the outer two terms, the inner two terms, the last two terms, combine like terms. And then you're going to multiply that by 2 and then add 5 to everything when you're through. So 2 times open parentheses. Now by FOIL, we have x squared. For the outer term, it's minus 6x. For the inner term, it's minus 6x, so minus 12x. For the last two terms, negative 6 times negative 6 is positive 36. Close parentheses, and then add 5 to this at the end. Now multiply everything through by 2, and we have 2x squared minus 24x. We're going to add 36 times 2, which is 72, to 5. 72 plus 5 is 77. So there it is in standard form. Now, a quick way to see what's going on is I recognize that the vertex is a positive number. So that means this is an upward opening parabola. Next, they're giving us the coordinates of the vertex. So if I were to do a crude sketch someplace, the vertex is at x equals 6. Oh man. I guess I'll have to extend my crude sketch a little bit. 1, 2, 3, 4, 5, 6. This is 5. So here's 6, comma 5. 1, 2, 3, 4, 5 is here. So the intersection of 6 and 5 is there. And what did I say? This thing is opening upwards. It never touches or crosses the x-axis, and therefore it has no real roots. And if it doesn't have real roots, then you can't write it in vertex form. It's unavailable. Vertex form is only available when it has real roots. When it has imaginary roots, they have to be complex conjugates of each other. So one has to be in the form of a plus bi, and the other root has to be in the form of a minus bi. And that doesn't fit the template for vertex form. Vertex form is always a, open parentheses, x minus the axis of symmetry value plus the y coordinate of the vertex. So doesn't fit, not compatible. Done with that one. A more interesting problem is the diving board. This was a challenge because it's 3 points that are given to you. It says the diving board will be 3 feet above the edge of the pool surface and extend 5 feet into the pool. So this coordinate, we're establishing the origin to be at the edge of the pool. The first coordinate will be at 3,5 feet. After doing some research, Split Splash Pools determined that the average diver would be 5 feet in the air when he's 8 feet from the edge of the pool. So not to scale. Remember, not to scale. I'm going to declare this to be 8,5. And the third point is he's going to be even higher. And maybe that's at the vertex, but we don't know. Maybe he's going to go 20 feet in the air before he's done going up. But he's now 10 feet from the edge of the pool, always measuring from the same origin on the left. So 10,6. Now this is almost the equation of a straight line. But it isn't. 3,5. And you should have spotted the mistake I made. It said he will be 3 feet above the edge of the pool when he's extended 5 feet into the pool. And I wrote 3,5. That is backwards. I should say that when he is 5 feet into the pool, he is 3 feet above the pool. Now this makes sense. 5, 3 feet 8 comma 5 feet, 10 comma 6 feet. And now we work our mathematical magic and say we need the equation of the one parabola that fits through all 3 points. Generically, y equals ax squared plus b times x plus c. We're going to set up a system of equations, plugging in the coordinates of each of the 3 points for x and y. So for the first one, 3 is equal to, now if x is 5, then x squared is 25. So 25a plus 5b plus c. For the second pair of coordinates, 5 is equal to 64 times a plus 8 times b plus c. For the third coordinate, 6 is equal to 100 times a plus 10 times b plus c. We have 3 equations and 3 unknowns. I'll label these as equations D, E, and F. And, well, like I did earlier, I would like to minimize how many negative numbers I have. So I'm going to do F minus D, and I'm going to do F minus E. And what that will eliminate is the variable C. Okay. So F minus D becomes 6 minus 3 is 3. 100 times A minus 25 times A is 75 times A. 10 times B minus 1 times B. I'm sorry. 10 times B minus 5 times B is still 5 times B. And the whole point of doing F minus D, C minus C is 0. They cancel out. Now I'll do F minus E. Again, I'm choosing this to eliminate C. I'm going to reduce this from a system of 3 equations with 3 unknowns down to a system of 2 equations with just 2 unknowns. 6 minus 5 is 1. 100 times A minus 64 times A is 36 times A. And 10b minus 8b is 2b. Or is it not to be? That is the question. And of course, c minus c is 0, which is why we're constructing 2 equations and 2 unknowns. Now, you can solve this by graphing, believe it or not. You can treat A as if it were X. You can treat B as if it were Y, and rearrange the equation that way and isolate A as an expression of X, graph it, and you'll find some intersection. I'm glancing at this, and it seems as if they are both going to have some sort of negative slope, one steeper than the other. And I can't tell you about x-intercepts, but if I have 2 straight lines with different slopes, there's going to be one unique intersection of 2 straight lines that have different slopes. So you can solve for this by graphing. If you want to do that approach, again, you would say let x be equal to A, let y be equal to B, or the other way around. Either way, you're going to get a single intersection, and that'll give you the values of x and y. The way I normally go about doing this algebraically instead of graphically is I try to find a way to eliminate by subtracting one expression from the other. I can see that the 5b and the 2b are pretty small numbers. I can eliminate them if I choose to multiply everything on this row by 2 and everything on this row by 5, and then subtract one from the other. How did I spot that? Because 2 times 5b is 10b, and 5 times 2b is also 10b. So that will set me up so that I can subtract one row from the other and eliminate b. So here we go. I'm going to take f minus d and multiply through by 2. 2 times 3 is 6. 75 times 2 is 150 times a. 5b times 2 is 10b. On the f minus e expression, when I multiply everything by 5, 1 times 5 is 5. 36 times 5 is where I pull out my calculator and I say, oh, calculator, what is 36 times 5? And it replies 180 times a. Meanwhile, 2b times 5 is 10b. I've now created a situation where I can subtract one expression from the other to eliminate b. I'm going to subtract, let's see, D, E, F, G, H, where G was equal to 2 times F minus D, and H was equal to 5 times F minus E. If you're wondering, how did I come up with what I have? F minus E. Well, I wanted to kind of resist negative numbers, but I'm going to have one way or the other. So I will go H minus G. 5 minus 6 is negative 1. 180 times A minus 150 times A is 30 times A. And the whole point of doing it this way is setting it up so that 10b minus 10b equals 0 and b is eliminated. I now divide both sides by 30, and I have a is equal to negative 1 divided by 30. There is one of my coefficients. I can now substitute back into equation G or H to solve for b. I'll go ahead and choose equation H. Okay, so 5 is equal to negative 180 divided by 30 plus 10 times b. That's equation H with a set in with its value of negative 130. Well, 180 divided by 30 is 18 divided by 3, which is 6. So really this says 5 is equal to negative 6 plus 10 times b. I'm going to add 6 to both sides. 11 is equal to 10 times b. I'm going to divide both sides by 10, and I have b equals 11 divided by 10. There's the second coefficient. Now I plug these back into equations D or E or F to solve for C. I think equation F looks like the easiest one. So let's say that 6, this is equation F, 6 is equal to 100 times negative 30 is negative 100 over 30. Imagine that is a minus sign there. Let's see, plus 10 times b is plus 11, because 11 divided by 10 times 10 is 11. And the last term is plus c, the one unknown that we have. If I subtract 11 from both sides, 6 minus 11 is negative 5. If I then add 100 divided by 30 to both sides, that will give me the value of c. Now, if I want these to have a common denominator, I should multiply -5 by 30 over 30. And that would give me, this is multiplication. 30 times -5 is -150. 30, 60, 91, yeah. Divided by 30. Then you're going to add 100 divided by 30 to that, and that will give you the value of C. Well, now that we have a common denominator, -150 plus 100 is -50 over 30, which simplifies down to -5/3 is the value of the C coefficient. I now finish off this problem by saying I have the quadratic equation set up as y equals -1 divided by 30x squared plus 11 divided by 10 times x minus 5 divided by 3. And of course, you should check these values in equations D or E and confirm that I haven't made a math mistake today, so far, in this recording. But they still haven't actually answered question 2. We've spent all this effort building the quadratic equation so that now we can go and answer question 2. It says, use the dive model shown to write an equation. Well, there it is. And then determine the minimum length of the deep section of the pool. It will be a minimum. We're assuming that when the person enters the water, they need to be over the 9-foot section. And that means we need to solve for when y has a value of 0. When the diver is at the surface of the pool. Now, there's going to be 2 solutions. They don't show this to scale, but, well, actually, I guess this would be to scale, or following the diagram, there's going to be a solution here and a solution there. Why? Because it's a parabola opening downward with 2 real roots. It's going to cross the water level twice. Now, once is before the diver leaves the diving board, and you're not allowed to solve a problem before it even begins. So since the diver is going up and to the right, we're going to ignore the solution that is before the diver has begun to go up and to the right. In other words, this is backwards in time. This one at the right edge is forwards through time, and that's the solution we want. To solve for this, oh my goodness, you have to find that value of x for which y is equal to 0. I suppose one way to do it would be to break out the quadratic formula and find the 2 roots. A little bit tedious, but -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, will get you to the answer. So if you are willing to plug it in, it would be -11 divided by 10, which is just -1.1, plus or minus the square root of, well, 11 squared is 121, and 10 squared is 100, so that's going to be 1.21, minus 4 times -1 over 30. That's good, because we get nervous when we're subtracting a positive number underneath the discriminant, times a, that was -130, times c, which unfortunately is a negative number, -5/3. And then you're going to divide that entire mess by -1 over 15. Yikes. I would be content to use a calculator. I'm going to go ahead and verify that it works. Another way you could do this if you have a graphing calculator is you just put the equation in. If you have a TI or equivalent graphing calculator model, you can type the equation in and then ask it for the root. I will do this that way. That's faster. I want to finish this up, right? You get to do it the hard way. So I'm going to type in negative 1 divided by 30 times x squared plus 1.1 times x, because that's what 11 divided by 10 is equal to, minus 5 divided by 3, enter. And I'm going to do a zoom standard. And you can't see it, can you? But I have Desmos installed, so I can go put this thing on Desmos. Oh, let me write down what the expression is. Negative 1/30th and 11 over 10th and minus 5/3. And let's go over to Desmos. All right, Desmos is our friend, right? There it is. So if I type in y equals, oh boy, negative 1 divided by 30 times x squared, and I see I didn't type it in correctly. Negative 1 times 30 times x squared. Great. It really is. Okay, so plus 1.1 x. Notice how that's, affecting the parent. Minus 5 divided by 3. Enter. Nice. So if I zoom in, I could probably ask it, what is the value of this point? And it says 1.592 on Desmos. That's very convenient. Nice. I didn't know it could do that. So there's a root. If I zoom in on here, and by the way, that's the root that takes place before the problem begins. The other root, way out here, past 30 feet, is the one that we really care about. And when I ask Desmos, oh, what is that? It says 31.408 feet. And so there's my answer, 31.4 feet. Thank you, Desmos. Okay, so that answers number 2. The answer is 31.4 feet is the minimum length of the 9-foot section of this pool. But wait, there was more to this homework assignment than just that. You were asked to find the intersection of these two parabolas algebraically. I see they are both parabolas opening upward because a is greater than 0 for each one of them. Algebraically, what I would do is I would set them equal to each other. So let's try that. This is the next problem in your assignment set, I think page 65, number 2. X squared plus 2x plus 1. I'm going to set that equal to 2x squared minus x minus 3. Combine like terms, simplify, find the intersections. I'm going to subtract x squared from both sides. I'm going to subtract 2x from both sides. I'm going to subtract 1 from both sides. Okay, well, now I could try to factor this, and some techniques you have are, what are two factors that when multiplied together are equal to -4, yet when you add them together they are equal to -3? And nothing is really coming to mind if you ask me. So, I mean, 1 and 4 Oh, that would work. 1 and 4. And we want this to end up being negative. So if I go plus 1 and minus 4, as a check by FOIL, first two, outer two, inner two, last two, I get x squared minus 4x plus 1x is minus 3x. 1 times negative 4 is negative 4. So I have two roots. So I have two solutions. And that shouldn't surprise you at all. One at x equals negative 1, and the other one at x equals 4. If you like, it says you can confirm this graphically. So let's see, we've got x squared plus 2x plus 1 and 2x squared minus x minus 3. Let's go back over to our friend Desmos. Hello, where's Mr. Desmos? There it is. Clear out the last problem because we don't need to know a previous problem anymore, do we? Boop. Great. And now I'm going to put in these two guys. So y equals x squared. It's fun to see Desmos work so hard. We graph it in real time, plus 2x plus 1. And then for the next equation, y equals 2x squared minus x minus 3. And it looks the way I would expect it to look. Two upward opening parabolas. Because they have different characteristics, they're going to have two intersections. Here's one of them that should be kind of obvious. That is negative 1 comma 0. Sure enough, that's one of the roots. And then when we pan, scroll, zoom, whatever you want to call it, farther up this curve, the intersection of these two parabolas seems to be about there at 4 comma 25 is the second root. So there you go. Thank you, Lord Desmos, for graphically showing us the solution. But there was one more part to your homework assignment, and that was do this one as well. And this is the last part of your homework. Find these two by intersection. Well, same process. I would set them equal to each other. I see that one is an upward opening parabola and another is a downward opening parabola. So they may have 0 intersections. They may have 1 intersection. They may have 2 intersections. And that's the limit of the possibilities. Let's go find them. 2x squared minus 7x plus 6. Set that equal to negative 2x squared plus 5x minus 3. As before, I'm going to combine like terms and simplify and treat it like a quadratic and find its roots. First, I'm going to add 2x squared to both sides. Notice that they do not cancel because one on the one side is positive, one on the other side is negative. So I add 2x squared to both sides to create 4x squared. I'm now going to subtract 5x from both sides. Negative 7x minus 5x is negative 12x. I'm going to add 3 to both sides. 6 plus 3 is 9. So there's my equation. I'm going to set it equal to 0 to find its roots. I glance at it and I see these are not all even numbers. They are not all multiples of 2, 3, or 4. So I can't do anything easy in my head. Now, some of you students are good at chunking, where you let u be equal to, let's say, 2x or something crazy, or doing the box method where you're looking for the factors of 36. That's from this business of the 4x squared goes here, the 9 goes there, and you're looking for factors of the product, 36x squared. That would be stuff like 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. 8, 9, 9. Okay, so that's the entire list. And then out of that list, what combinations do you have that might work out to be a sum of negative 12 and a product of 9? So they would both have to be negative numbers to end up with a positive answer product, and they have to sum to negative 12. Well, 1 and 36 add up to 37. That's ruled out. 6 and 6 add up to 12. So that's ruled in. 4 and 9 is 13. 3 and 12 is 15. 18 and 2 is 20. So I'm going to say 6x and 6x go here. And then you sort out, what can you factor out from these? You can factor out a 3. You can factor out 2x. You can factor out a 2x. You can factor out a 3. And make these both minus signs. So it looks like this becomes 2x minus 3 quantity squared is equal to 0. Let's do a check using FOIL. So 2x times 2x is 4x squared. 2x minus 3 is minus 6x. Minus 3 times 2x is minus 6x. And negative 3 times negative 3 is positive 9. So yes, this checks that I have correctly factored this thing. And the roots of 2x minus 3 are x equals 3 halves with a multiplicity of 2. So they do indeed touch each other at one point. But being crazy parabolas and quadratics that they are, that one point is a double hit. So it bounces. They bounce off of each other at one location. I think that's how you students would express it. And of course, you should check that back in the original expression, put in x equals 3 halves everywhere, and confirm that you get the same result out. What I'm going to do is just graph these two things on our friend Desmos. Yes, 2x squared minus 7x plus 6 and minus 2x squared plus 5x minus 3. Let's go over to Desmos and see what we can see. All right, y equals x squared. Or am I doing the wrong one? I think I started doing the wrong one. I'm supposed to be doing 2x squared. Yeah, I'm doing the wrong one. Okay, back over to Desmos and fix my mistakes. We're doing 2x squared. Trying to get out of it. I see. Minus 7x plus 6. Nice. Second one, y equals negative 2x squared plus 5x minus 3. Okay, so here in Lord Desmos, or Prince Desmos, whatever you want to call it, we have an upward opening parabola and a downward opening parabola. And when we zoom in, let's zoom in some more, we don't see an obvious crossing of one over the other. That's because they just kiss each other at one point, and that is at x equals 3 halves, which is 1.5, comma 0. Okay, so that is the common point of intersection for these two equations. If you put in x equals 3/2 into both equations, you should get out y equals 0. This concludes the debrief on, let's get back over here. This is the debrief on Fall Homework 01.